Dear students, in the previous classes we have discussed demand, supply and market equilibrium. In our analysis, we have shown that quantity demanded of x is a function of price of x, prices of substitutes and complements, income of the consumer, and taste and preferences, plus the number of consumers in the market. And if there is a change in any of these variables, quantity of demand changes. So we are interested in the magnitude of the change in quantity demanded to a change in any of these factors: price of the commodity, prices of substitutes and complements, income of the consumer, taste and preferences, etc. We use what is known as elasticity of demand. We use the concept elasticity of demand. And elasticity of demand measures the relative responsiveness of the amount purchased per unit of time. Relative responsiveness of the quantity purchased per unit of time to a change in any of these variables. To a change in any of these variables, keeping other factors constant. So, elasticity of demand measures the relative responsiveness of the quantity demanded of x to a change in any of these factors, keeping the other factors constant. For example, the law of demand states that as price increases, quantity demanded decreases. There is an inverse relationship between price and quantity demanded. But this law of demand will not tell us the magnitude of this decline. Law of demand simply states that there is an inverse relationship between price and quantity demanded. It will not tell us the magnitude of this decline. That is, how responsive is quantity demanded to a change in price. How responsive is quantity demanded to a change in price. Now, to measure the magnitude of the responsiveness, we use what is known as the derivative or the slope of the demand curve. To measure the magnitude of responsiveness, we use the derivative or the slope of the demand curve. For example, if there is a change in one variable x, and suppose that it affects another variable y, then that is, if y is a function of x, if there is a change in x and it affects y, then dy by dx measures the responsiveness of y to x, and larger the value of this derivative, larger will be the magnitude of responsiveness. So one measure of responsiveness is the slope of the demand curve. Slope of the demand curve. And this is mathematically denoted as dy by dx. If y is a function of many arguments, we use the partial derivative dou y by dou x, partial derivative. If y is a function of x only, dy by dx. That is it. Now, one problem in using the slope or the derivative as a measure of responsiveness is unit of measurement. Unit of measurement. One problem in using the derivative as a measure of responsiveness, as a measure of change, is the unit of measurement. Stated differently, if we change the unit of measurement, say from dollar to cent, from rupees to paise, when we change the unit of measurement from dollar to cents, from rupees to paise, the magnitude of change is affected, or the value of the slope or the value of the derivative is affected. So when we use slope as a magnitude of change, it is affected by the unit of measurement. Suppose that y is measured in pounds and x is measured in dollars. Suppose that y is measured in pounds and x is measured in dollars, and also that dy by dx is 2. Dy by dx is 2 means 2 pounds per dollar. 2 pounds per dollar. That is, if x increases by $1, y increases by 2 pounds. That is the meaning of derivative, as the derivative is positive. Now suppose that y is changed from pound to ounces. Is changed from pound to ounces. X is measured in dollars itself. Then you will get dy by dx as equal to 32, because 1 ounce is equal to 1 pound is equal to 16 ounce. 16 ounce. So by simply changing the unit of measurement of pounds of y from pound to ounce, the derivative changes from 2 to 32. So slope or derivative depends on the unit of measurement. So what we want is, as a measure of responsiveness, is a unit-free measure. What we want is a unit-free measure. As a measure of responsiveness, we want a unit-free measure. And to obtain the unit-free measure as a measure of change, we use what is known as the standardized derivative. the standardized derivative. And the standardized derivative is known as elasticity. As a unit-free measure of responsiveness, we use the standardized derivative or the standardized slope, and this standardized derivative is known as elasticity, and elasticity removes what is known as the scale effect. Now, how this is actually obtained? What is meant by the standardized derivative? The derivative is standardized, means it is converted into elasticity by weighting the derivative with the levels of the variables under consideration. We standardize the derivative into elasticity by weighting the derivative with the levels of the variables under consideration. And when we weight the derivative with the levels of the variable under consideration, it results in percentage change in y given a percentage change in x. So elasticity, standardized derivative, measures percentage change in y resulting from a given percentage change in x, and it is unit free, independent of the unit of measurement. So this measure of responsiveness, elasticity, is independent of the unit of measurement. That is, if y is a function of x, then dy by dx is the derivative of y with respect to x. Now, the elasticity or the standardized derivative of y with respect to x, denoted as epsilon, is equal to percentage change in y divided by percentage change in x. The standardized derivative or elasticity is nothing but percentage change in y divided by percentage change in x, or it is the limit of, we write it as the limit of delta percentage change in y divided by percentage change in x as delta x approaches to 0. Limit of percentage change in y by percentage change in x, or it is the limit of, as delta x approaches to 0, delta y by y divided by delta x by x, delta x by x, or it is equal to dy by dx into x by y. It is dy by dx into x by y. This step is not required. So epsilon, elasticity of y with respect to x, that is the standardized derivative, is the limit of percentage change in y divided by percentage change in x as delta x approaches to 0. That is limit of delta y by delta x, delta y by y divided by delta x by x, and it is nothing but dy by dx into x by y. That is, the derivative is weighted by the value of the variables x and y. If epsilon is equal to, say, 3, if epsilon is equal to 3, then it means that a 1% increase in x causes 3% increase in y, or a 1% decrease in x causes a 3% decrease in y, like that. If the value of epsilon is 3. Epsilon is the notation for elasticity of y with respect to x, and this is it. Remember this. So, elasticity is a unit-free measure. Elasticity is independent of the unit in which x and y are measured. So, we use this standardized derivative elasticity as a measure of responsiveness, because we always want what is known as the unit-free measure. Now, and since a percentage change measure, this epsilon can also be written as elasticity is a percentage change, this can also be written as equal to d ln y by d ln x, can also be written as d ln y divided by d ln x, because d ln y is dy by y, d ln x is dx by x. So, it is the limit of delta y by y divided by delta x by x. And you know that delta and d are conceptually same. This delta becomes d as delta x approaches to 0. And this is the elasticity measure. It is independent of the unit of measurement. The slope is weighted by the levels of x and y. And we use this measure to study the relative responsiveness of quantity demanded to a change in price under the heading price elasticity of demand.